Okay, this is instantaneous velocity and acceleration, Giancoli 2.3 to 2.4. Instantaneous velocity is the average velocity in the limit as the time interval becomes really, really small, right? So essentially, that's your velocity at any given time. So we have two different graphs here, and you can see this graph, the velocity is constant, which means your instantaneous velocity is going to be the same as your average velocity. But in this case, here's our average velocity for the trip in the dotted line in this graph, and you can see your instantaneous velocity can be anywhere along this chart. So essentially, there's only two spots in this half a second or half hour of travel where your instantaneous velocity and average velocity are the same. And this will be the calculus reason why. Obviously, there's no calculus to do here, but just understand that we can solve for instantaneous velocity by using limits and graphing, of course. So exercise B asks, what is your instantaneous speed at the instant you turn around to move in the opposite direction? And here's your question. A, depends on how quickly you turn around. B, always zero. C, always negative. Or D, none of the above. So the instantaneous speed at the instant you turn around to move in the opposite direction, it will definitely become negative because you're going to, not speed, I'm sorry, your velocity. Well, your speed will not. Your speed will stay constant. Will stay positive. Would it be zero? If you do stop, then yes, it'll be zero. And then A, depends on how quickly you turn around. Maybe, but it will. It's A and B both. It depends on how quickly you turn around, and then of course it could be zero, but not always zero. So I think B would be a misnomer to say it's always zero, because your speed you could keep moving as you move in the opposite direction, but definitely not negative because speed is a scalar. Okay, now we're going to talk about acceleration. Acceleration is the rate of change in velocity. So average acceleration is change in velocity over the time elapsed. So what we do in this diagram below, here's our velocity at time zero. Here it is after 1 second, 2 seconds, 3 seconds, or 5 seconds. And as you can see, for every second that we travel, our velocity increases 15 kilometers per hour. Hence, there's our acceleration. Now, acceleration is a vector, okay? And in one-dimensional motion, we just used the sign to show that. So we saw positive acceleration in the first example. Now, here's an example of negative acceleration. We are going to the right at 15, and we slow down to 5. Our acceleration, as you see here, is negative because our speed is slowing down. So our acceleration is going to the left while our velocity is going right, which means we're slowing down. If the vectors go in opposite directions, you're slowing down. But there is a difference between negative acceleration and deceleration. Negative acceleration means that your acceleration is going in the negative direction. So let's say you're going to the left now and you're speeding up. If you're going to the left and speeding up, then your acceleration is negative still. But now deceleration occurs when the acceleration is opposite the direction of the velocity. So in this case below, we're traveling to the left, but slowing down. So we're traveling negative, but slowing down, which means our acceleration is going to the right, or it's going to be positive. And you'll see plenty of examples of this to try to get this through your head a little bit. It's not the easiest thing to try to gather in the first time you talk about it. The instantaneous acceleration is the average acceleration in the limit, just like we talked about with instantaneous speed. And again, could this come up? Yeah, if you have a graph, you could find instantaneous acceleration. Read this problem. Okay, as we talk about acceleration, we add another equation to the board. Acceleration is equal to v2 minus v1 over change in time. So essentially, it's our final velocity minus our initial velocity over change in time. And that equation is added to the ones that we were previously using to try to solve some of these problems. So example 2.4 says a car accelerates on a straight road from rest to 75 kilometers per hour in 5 seconds. What is the magnitude of its average acceleration? Okay, so first off, it says from rest. Rest means your velocity in this case is not moving, which means it's zero. So if I want to find the acceleration, my initial velocity is going to be zero. My final velocity was 75. time was 5 seconds. So 75 minus 0 divided by 5 would be how I would solve this. So I take my 75 divided by 5, and I get 15 kilometers per hour per second. Distance, time, time. Now, we like to keep things consistent, and you can do conversions if you need to get this answer in the units you want. But based on the data given, this is what I got as my acceleration. 15 kilometers per hour is my increase, right? It's a positive number per second, and that's my acceleration in the positive direction. We will do it. All right, so we read this example. It says an automobile is moving to the right along a straight highway, which we chose to be in the positive x-axis. So what we're saying is the right is going to be positive. Then the driver steps on the brakes. If the initial velocity, so that's when the driver hits his brakes, is 15 meters per second, and it takes 5 seconds to slow down to 5 meters per second, what is the car's average acceleration? So we're traveling this way. We start at 15 meters per second, and our speed slows down to 5 meters per second. And we want to find the acceleration. So first off, our final velocity in this case, so V2 is 5 meters per second, which is 5.0, minus our initial, which is 15.0 meters per second. And we divide that by our change in time, which is 5 seconds. We can solve. So we take 5 minus 15, we get negative 10 divided by 5, and it's negative 2. So 2 sig figs minus 2.0 meters per second, and this is in seconds. So meters per second squared, which is what we normally see. The sign's negative because our velocity, even though we're heading in this direction, it's slowing down. So our velocity is actually going into the negative direction, even if we're heading positive. So our acceleration is negative. We're slowing down in the positive direction. Our acceleration is negative. Velocity and acceleration. If the velocity of an object is 0, does it mean that the acceleration is 0? So if your velocity is 0, are you accelerating? No. Are you changing your velocity? No. So your acceleration can be 0 if your velocity is 0. B, if the acceleration is 0, does it mean that the velocity is 0? For sure not, because your velocity, all 0 acceleration means is that you have constant velocity. So your velocity could be 0, but it also could be 10, and it could be 15, as long as it's constant. And those are your examples. Please read this problem. All right, so we read this example. It says an automobile is moving to the right along a straight highway, which we chose to be in the positive x-axis. So what we're saying is the right is going to be positive. Then the driver steps on the brakes. If the initial velocity, so that's when the driver hits his brakes, is 15 meters per second, and it takes 5 seconds to slow down to 5 meters per second, what is the car's average acceleration? So we're traveling this way. We start at 15 meters per second, and our speed slows down to 5 meters per second. And we want to find the acceleration. So first off, our final velocity in this case, so V2 is 5 meters per second, which is 5.0, minus our initial, which is 15.0 meters per second. And we divide that by our change in time, which is 5 seconds. We can solve. So we take 5 minus 15, we get negative 10 divided by 5, and it's negative 2. So 2 sig figs minus 2.0 meters per second, and this is in seconds. So meters per second squared, which is what we normally see. The sign's negative because our velocity, even though we're heading in this direction, it's slowing down. So our velocity is actually going into the negative direction, even if we're heading positive. So our acceleration is negative. We're slowing down in the positive direction. Our acceleration is negative. problem, and we will do it. All right, so a car moves along the x-axis. What is the sign, so negative or positive, the car's acceleration if it is moving in a positive x direction? So we're going this way. All right, so x, and it's positive. And it says A, increasing speed. So that means our speed is going from here to here. It's increasing, all right? So that means our acceleration is going to go in the same direction, which means our acceleration will be positive. It says B, decreasing speed. So we're moving x in the positive direction, but now our velocity is slowing down. So if acceleration is going, if our velocity is slowing down, our acceleration will go in the opposite direction, which in this case would be B. Now for C and D, what is the acceleration if the car moves in the negative x? So now our x, okay, it's in the negative direction. So if we're moving in to this way, it's a negative direction. If we're increasing speed, since we're increasing speed in the negative, our acceleration will be negative. And if we're decreasing speed, so if we're going in the negative and decreasing speed, we're going opposite, which means our acceleration will be positive. And keeping track of signs will make things easier as we go on with the math. Oh, almost forgot this one. Please read this problem, and we will do it.